All right, there are several types of problems in 7.1. One of them are some old problems where we're going to solve by taking square roots. And they're kind of doing that to get us ready for the new idea they're going to present to us. So I thought we'd look at number 5 just as that little review. We've done things where we have x squared is negative 4, and if we're going to square root both sides, we need to put a plus and a minus to show that we square rooted to solve. And that would be plus or minus 2i, because the square root of negative 1 is I and the square root of 4 is 2. Now in 5b, they give us a little bit more to that. What if you have a perfect square, but it's in parentheses and you have it equal to a number? Well, we can still solve that by square rooting both sides. So we'll do that, and because I square rooted, I need to put a plus or minus on the outside of that number. The square root of x plus 7 squared is x plus 7, and then I have plus or minus, and again, the square root of negative 4, just like it was over here, is 2i. So if I wanted to solve for x, I could subtract 7 from both sides, and I get two answers. I get negative 7 plus 2i and negative 7 minus 2i, which we usually write it as negative 7 plus or minus 2i, but those are the two answers that we get. You could split them up like that, or you could write it as one just to save yourself some writing. And then on the C part, they say, okay, let's make it a little harder. Let's make it 2x plus 7 squared is negative 4. Okay, and with these, I remember when we did these in Algebra 1, that we had a little trouble with them because when you square root both sides, a lot of people want to think it's just going to be two of the same things like it was on the B part, but it doesn't always work out that way. The square root of 2x plus 7 is 2x plus 7. Because I square rooted over here, I need a plus or minus, and again, the square root of negative 4 is 2i. That was the answer we actually found up there on A. Now, if I'm going to solve for x, I have two equations to solve. One of them is 2x plus 7 equal 2i, and one of them is 2x plus 7 equal negative 2i. So we have to solve two separate equations here. So if we subtract 7 from both sides, we get 2x is negative 7 plus 2i. And then if I divide everything by 2, I end up with x equal negative 7 halves plus I. That's one of my solutions. Now let's go over here. If I subtract 7 over here, I get 2x equal negative 7 minus 2i. And then if I divide everybody by 2, I get x is negative 7 halves minus I. So actually I could write those two together as negative 7 halves plus or minus I. Just be careful. A lot of times, just because of the algebra on there, sometimes things end up, sometimes it's not exactly the same thing on both solutions. It was here, though. It just depends on the way the problem's set up. All right. They kind of did that to review us about solving with square roots to show us why we might want to complete the square. Now, I can complete the square on anything, but it's not always the most fun or quick way to solve a problem, so a lot of people don't use it. The reason we do need it is with conics, and we're going to need it then. All right, so I'm going to pick a problem to do completing the square on. I'm going to choose number 13 just because it's got the negative in it, and I know sometimes that there's some things there to talk about. So if I have an equation, I want to complete the square, what I do is I first move the constant to the other side. So move constant to other side, all by itself. So that means here I will add 5 to both sides. That's step 1. So now I have x squared minus 2x equal 5. And I'm leaving a space there because what I'm going to do is I'm going to add b over 2 squared to both sides. Now, why am I saying b? Where's this b coming from? Well, if you remember up here, we could have labeled this as ax squared plus bx plus c. So my b here would be negative 2. So I'm going to add to each side the b, which is negative 2, divided by 2, and squared. Well, what is negative 2 divided by 2 squared? What is that on the inside? Negative 2 divided by 2 is actually negative 1 squared, isn't it? So what is negative 1 squared? Negative 1 times negative 1 is positive 1. So I'm going to actually add 1 to both sides. Now, I wrote it that way on the right because I need to, in the next step, say, okay, what I just did was I created a perfect square. And that perfect square is x, and it's whatever was inside that square thing. Let me circle it. Whatever it ended up being on the inside of here, that's what goes right here. Let me write it in red. That's x minus 1 squared. And I could have written it the same way on the other side, but I just was trying to do some simplifying so I didn't have to write another whole line just to simplify that. Negative 1 squared is positive 1, and so on the other side I have a 6. Now that I did that, I have turned this equation into a perfect square, and now I can solve it like we did the problems on number 5 up above. By the way, I want you to multiply out x minus 1 squared. Let's check to make sure that what we have here is really what we started with up here, x squared minus 2x plus 1. Okay? If I multiply that out, it would be x squared, oops, minus x minus another x would be minus 2x, and then negative 1 times negative 1 would be a positive 1. That positive 1 is what I added to this other side. But a lot of times we just leave it written this way as negative 1 squared on this left-hand side where I circled it in yellow just so I'll know that's what I'm supposed to put down here. Now that I've got it, I can solve this by square rooting both sides. So I'm going to square root both sides. The square root of x minus 1 squared is equal to the square root of 6, and because I square rooted, I have to put a plus or minus on it. Well, the square root of x minus 1 squared is just x minus 1. So I have plus or minus square root of 6 on the other side. Now if I want to solve for x, all I have to do is add 1 to both sides. So x is equal to 1 plus or minus square root of 6. That's two answers. One answer is 1 plus square root of 6. Another answer is 1 minus square root of 6. It's just this is the quick way of writing it. Now when we do these things, one of the things that I didn't mention up here because I didn't need to was that we can only do this if the coefficient up here of this x squared term is 1. If it's not 1, I'm going to have to divide the equation through by that and get rid of that number and make it just a variable squared. I can't have like 2x squared there and complete the square. I got to get rid of it. And I do that by dividing things out. So let's pick one like that and do one like that so I can demonstrate that to you. Okay, I think the only one I really assigned to you that had a number out front was number 21, 2t squared plus 4t plus 1 equals 0. And so I'm going to solve this by completing the squared. You remember we have other ways of solving it. We could try to factor it. We could try to use the quadratic formula. But one of the ways that we can do it is to make it into a perfect square so I can solve it by using square roots. And that process of making it into a perfect square is what we call completing the square. So one of the things I'm going to do here, let me go ahead and move the constant to the other side. And that gives me 2t squared plus 4t equal negative 1. Now I cannot complete the square with this 2 out front. I've got to divide everything by 2 because I've got to have just a plain old t squared. So let me go do that. And unfortunately everybody gets divided by 2 and I do end up with a fraction on the other side, but that's not that big of a deal. These 2 cancels out and I get a t squared. Now 4 divided by 2 is 2t. And over here I have negative 1/2. Now, so I've moved the constant to the other side. The next step is to take the b, which is the coefficient of the middle term. Right here it's this positive 2. So I'm going to take that 2 and I'm going to divide it in 2 and square it. You always take the b divided by 2 and you square it. That's what you do, and that's what you add to both sides. Well, 2 over 2, that's just really a positive 1, isn't it? And so what is 1 squared? Oh, it is 1. So I could put plus 2 over 2 squared on the other side, but just to save myself some time, I'm going to go ahead and reduce that and just put plus 1 over there. Okay, so what that did is that created a perfect square. And if you don't believe it, you can multiply it out and see that it's the same thing. I have t squared plus 2t plus 1 squared. So this becomes t and then plus, and then whatever's inside of the parentheses, which here it's a positive 1, that's what I write there. That's my perfect square. Multiply it out and you'll see that you would get t squared plus 2t plus 1. Alright, on the other side I have negative 1/2 plus 1. That's a positive 1/2. Now that I have this, I can actually solve this problem by square rooting both sides. So sometimes if you hate the quadratic formula and you can't factor something, this is another option. The square root of t plus 1 squared is just t plus 1. Now I square rooted, so I should write a plus or minus on that 1/2 on the other side, and that is the square root of 1 over the square root of 2. Now I know I'm going to have to get that all rationalized, so let me go ahead and multiply by square root of 2 over square root of 2 so that I don't have a radical in the bottom. So this is going to become t plus 1 is equal to plus or minus square root of 2 over 2, because square root of 2 on the bottom times square root of 2 is 2. Now in order to solve this, what I'm going to do is I'm going to subtract 1 from both sides. And let me come up here because I'm almost out of space. That t is equal to -1 plus or minus square root of 2 over 2. That's my solution. Now, sometimes books do crazy things. Let me just look and see what yours does. Okay, no, it leaves it just like this. So this is my answer right here. That's two answers. Just want you to realize that's two answers. One answer is -1 plus square root of 2 over 2, and another answer is -1 minus square root of 2 over 2. We're just writing it that way because it keeps us from having to copy it twice. Now, where this gets tricky is if you had like -1 plus or minus 3. I don't know if y'all remember that, but some of y'all had trouble. That's what I was referring to earlier. If you had something like that and you had to simplify it, it wouldn't end up being plus or minus the same number. It'd end up being two different numbers. So just be really careful. As long as you've got a radical, it's almost easier when you have the radicals in the equations because it keeps you, a lot of times you can't simplify further. So sometimes something that makes it look hard actually makes less work for us. So anyway, there's some examples there to help you get going on completing the square.